Assalamu alaikum students, I am making this video to explain the third worksheet of static electricity. Question 1 says figure 8.1 shows the charges on a rod and a cloth. As you can see in the diagram, there are equal number of positive and negative charges in the cloth as well as in the rod. If you count the total number of positive charges and negative charges in the both rod and the cloth are going to be equal. The total number of charges in cloth may be different to the total number of charges in the rod, but the total number of positive and negative charges in both objects are equal. State how figure 8.1 shows that the rod and the cloth are uncharged. So that is how it shows it is uncharged. They are having equal number of positive charges and negative charges. Equal number of positive charges and negative charges on the rod, equal number of positive charges and negative charges on the cloth. The plastic rod becomes negatively charged when rubbed by the cloth. Describe what happens to the charges on the rod and on the cloth during the charging process. So the question said clearly that the rod is becoming negative charge. The rod becomes negative charge. The rod can becomes the rod will become a negative charge object only when electron transfer from the cloth to the rod. So some of the electrons in the cloth are transferring from cloth to the rod. So the rod is going to gain excess negative charges, extra electrons, and the cloth will lose some electrons. As a result of that, cloth will become positive and the rod will become negative. So in here is in our answer, in our description, we have to explain that electron transfer from cloth to the rod, and rod gains extra electrons and rod becomes negatively charged. Cloth loses electrons and cloth becomes positive. Describe a simple experiment to show that plastic rod is charged. You may draw a diagram if you wish. So you can demonstrate a simple experiment how you can prove that the plastic rod is charged. You can use a Venn graph. You can use a gold leaf electroscope. The gold leaf electroscope consists of a rod, T-shaped metal rod, and there will be a small piece of gold leaf here. So once we bring the rod close, this place is kept in a box to minimize the effect of deflection due to air, because the gold leaf there is very light. So once you bring the rod, negative charge rod here, all the electrons in the metal plate will move down, will move bottom part of the gold leaf electroscope. So this part will become negative and the gold leaf will also become negative, and negative charge and negative charge will repel each other. The top part of the gold leaf electroscope will remain positive. So due to this charge induction, there will be a small deflection in this gold leaf. The gold leaf will deflect away from the metal rod. So that shows that this rod is charged. If this rod is not charged, then this one will not become positive. Electrons will not move to the bottom part of the gold leaf electroscope, so there won't be any deflection. So this is a small experiment you can do to show that this rod is charged. Question 2. An uncharged piece of metal P rests on an insulator. A positively charged rod is placed close to P as shown in figure 7.1. State the material that is an electrical insulator. So you can write plastic, polythene, wood, any insulator that will be accepted. On figure 7.1, draw the distribution of charge P. So distribution of the charge on P. So since we are having a positive charge rod above metal P, here's the metal P, the upper part of the rod will be metal P must be negative, because electrons will attract towards the positive charge rod, towards this rod. So the bottom part of this rod will be positive. You should draw equal number of positive charges and negative charges on the rod. So it is advised not to draw a lot of charge. If you draw 20 negative charges, then you have to draw 20 positive charges. So you can draw a lesser amount like 5, 7, between 5 to 7 charges. P is then connected to earth by the wire as shown in figure 7.2. So here is an earth wire connected. On figure 7.2 show the distribution of charges on P when the earth wire is connected. So when the earth wire is connected, the negative charges will still remain at the top, but the bottom part is before positive. To neutralize that part, electron will move from ground, from earth, and then will neutralizes the bottom part of the metal plate. So the bottom part of the metal plate P is now going to be neutral, the upper part is still negative. So this is going to be our diagram when we connect an earth wire. State what happens to the charges on P if the positively charged rod is removed with the earth wire still connected to P. So if you remove this positive charge rod with this wire, if you don't remove the wire, if you keep the wire still connected, and if you remove the positive charge rod, now the positive charge rod is not there, then these electrons don't have any reason to stay at the top part of the metal plate P, so the electrons will move back to earth. Electrons, the extra electrons, that will be extra electrons, so those electrons will flow back to earth. So the metal plate P will become neutral if we remove the positive charge rod keeping the earth wire. So that is the situation, that will be the consequence of removing the positive charge rod and keeping the earth wire. So the second part says after earth wire is disconnected from P. So first we are disconnecting earth wire, then we are removing the rod. Then what will happen to the negative charge remained here? So that time, in that case, the negative charge will remain. Negative charge cannot flow back to earth because the earth wire is not there, because we are first removing the earth wire after earth wire is disconnected. So first we remove earth wire, then we are removing the positive charge rod. So now the negative charge will remain in the metal plate P. Before, in this answer, we have to write the negative charge will flow back to earth. Here the negative charge will remain in the metal plate P. So that is the answer for the part 1 and part 2 of the second question. Question 3. When a balloon is rubbed on a hair, the balloon becomes negatively charged. The balloon is shown in figure 5.1. Explain how rubbing causes the balloon to become negatively charged. So this is a very similar question as the first one. So when we rub two things together, electron transfer occurs, and here the question says the balloon is becoming negatively charged. That means electron transfer from hair to balloon. So our answer should include, the first sentence is electron transfer from hair to balloon. Balloon gains extra electrons, extra negative charges, and becomes negative. Hair loses electron and become positive. But in this question we are not asked to explain what happens to hair, so you can leave it. But you have to explain that electron transfer from hair to balloon. Balloon becomes negative charge because it gains extra electrons. Part B. Explain why the hair is pulled towards the balloon. Now, once this is rubbed, the balloon is negative and the hair is positive. So, since the negative charges and positive charges are unlike charges, they attract each other. So, our answer for B part is hair is positive charge, balloon is negative charge, and unlike charges attract each other. Explain why it is important that the balloon is made from an electrical insulator. If it is made of electrical conductor, then electrons can flow easily through them. If it is insulator, electrons can't flow, so electron can store. If it is a conductor, electrons can be lost to the easily, because electrons can move around easily. So if it is an insulator, it can contain it for some time, so it can maintain the charge. So it is important when we do static electricity experiments to charge insulators, because conductors can carry electrons easily, and it can lose electrons easily. But if it is insulator, electrons will remain stuck there for some time. So that is the answer for C part. Part D. State one example where static electricity is useful. We use static electricity in electrostatic precipitators to reduce the air pollution. We collect the dust particles that comes out from chimneys, We also use static electricity for car painting to get a smooth, nice painting. We also use static electricity in photocopy machines. So we can write one of those, you can write one of those answers. A student rubs a polythene rod with a dry cloth. The polythene rod becomes negatively charged and the cloth becomes positively charged. Describe in terms of movement of electrons what happens during the charging process. So we are using a polythene rod and a dry cloth. A polythene rod and a dry cloth. So the question said very clearly, the polythene rod is becoming negative charge. So here this is the negative charge and the cloth is positive. So we have to describe the movement of electron. So movement of electron is from positive object to negative object. So electron has transferred from cloth to polythene rod, because polythene rod is negative and cloth is positive. There is an electric field around the charge rod. Explain what is meant by electric field. Electric field is region around charge object. Every charge object there will be a region around it which other charge objects experience the force of attraction or repulsion. In this case it is a positive object and a negative object. Rod is positive, cloth is positive and rod is negative, so they both will attract. It will attract only once it enters the other one's electric field. So it is a region, the description says it is a region around charge object where other charge objects experiences the electrostatic force. The charge rod is placed near a stream of water from tap as shown in figure 5.1. This is also a simple experiment. We can demonstrate that the rods are charged. In the first part of the first question, there was us to demonstrate experiment, write an experiment, how to demonstrate that the rod are charged. So I explained that electrostatic, the gold leaf electroscope. So this is also a small simple experiment you can do. So once we bring this rod, the negative charge rod, close to the stream of water, what happens? The stream of water bends because the rod is charged. Explain how the charge on the rod causes positive and negative particles in the water to move. So as we know that the negative charge or the negative particles won't like the rod, so it should move away from the negative charge rod, and the positive ions will remain close to the negative charge rod. So that is how the distribution of positive and negative particles. Actually electrons can flow, but if it is a water molecule, an ionized water molecule, the water molecule also can flow. So the negative molecule will move away from the rod and the positive molecule will remain close to the rod. On figure 5.1, draw a charge present on the stream of water. So I have just drawn the diagram. You can also, I will just demonstrate it again here. This part of the, this side will be, sorry, that is, this side of the water is going to be this side is going to be negative and this side will remain positive. So that is how the charge distribution or the diagram will look like. So we can draw next to the water stream to demonstrate the charge distribution inside the water. So that is the end of the discussion. That is the end of the worksheet. I hope you all did well. We will be posting another lesson today. Good luck. Thank you.